You can use this method of improper integrals to evaluate areas underneath functions not only on infinite domains, but functions that have discontinuities. So let's look at this function, 1 over 1 minus x. So let's give ourselves a sketch of the graph to understand what we're talking about. This function has a vertical asymptote at 1, a horizontal asymptote at 0, and a y-intercept of 1. So it's going to look something like this. And our job is to ask, does the integral between 0 and 1 exist? So if we integrate from 0 over to this vertical asymptote, is it going to have a finite amount of area underneath it? And it's not obvious because this function is growing infinitely. So let's evaluate the integral from 0 to 1 of 1 divided by 1 minus x. So we will approximate the integral by integrating from 0 to alpha. So let's put maybe alpha on somewhere on the left-hand side of 1, and we'll integrate up to alpha. The function 1 over 1 minus x. And then once we have that answer, that's going to be a finite area. And then once we have that area, we will then send alpha to that vertical asymptote. We're going to send it to 1. So we will take the limit as alpha approaches 1, and it's approaching on the left-hand side. So it's a left-hand limit. Okay, so let's run through this. We have the limit as alpha approaches 1 from the left, and an antiderivative of 1 divided by 1 minus x by a u substitution will be a minus natural log of absolute value 1 minus x, which we will evaluate between 0 and alpha. All right, so we have our limit. Alpha will eventually get sent to 1 on the left-hand side, and I can get rid of that negative by switching the order of the integration, by switching my bounds. So I'll evaluate natural log at 1 minus 0 first, and then subtract natural log absolute value 1 minus alpha. Okay, so this term here doesn't have any alphas in it. It's a constant as far as this limit is concerned. So the limit is going to move past it. Let's go ahead and evaluate it. 1 minus 0 is a 1. Absolute value of a 1 is a 1. Natural log of 1 is a 0. So this whole term is just 0. And then we have minus limit alpha approaches 1 from the left. Natural log absolute value 1 minus alpha. Okay, so we have minus limit alpha is approaching 1 on the left-hand side, natural log. And if alpha is approaching 1 on the left-hand side, let's go to our picture. If alpha is somewhere over here, then it's smaller than 1, meaning that 1 minus alpha is a positive number. So I can just ignore my absolute values. As long as alpha is close to 1, as long as it's smaller than 1, which it is because we're approaching on the left-hand side. So what happens to this function? As alpha approaches the value of 1, well, if alpha approaches the value of 1, then 1 minus alpha approaches the value of 0. And if you think about your natural log function, the natural log, as you get closer and closer to 0, decays towards minus infinity. So we have minus infinity, or infinity. So this integral did not give us a finite amount of area. This integral diverges. The area is infinite.